Hello viewers, welcome to video number 65 of Chemphilic. Video number 65 is the 7th episode of Chemical Thermodynamics. And in this 7th episode, I will discuss about reversible and irreversible processes. So let's start. Reversible process. What is that? It is carried out, reversible process can be carried out through a large number of or infinite number of infinitesimally small steps. That means large number of small steps. This is first criteria. Then all the changes occurring in the direct process can be exactly reversed. What does it mean? That means any forward process can be easily reversed back. You can take it in the backward process. Okay. Then next criteria, the system in reversible process, system remains almost in a state of equilibrium at all the times. And the fourth criteria, work done in a reversible process is maximum. So, we'll explain all these criteria. Just imagine this is a gas is enclosed in the cylinder which is attached with a movable piston, and above the piston we have taken some small sand particles on a funnel. Now, when the piston is in the static position here, then pressure of the gas which acts in the upward direction will be equal to the external pressure or downwards pressure. Downwards pressure means atmospheric pressure, weight of this piston and this weight of the funnel and the sand particles. Of course, in reversible process, we consider weightless, frictionless piston, all these things, but practically that is not possible. So, external pressure acting downwards is the weight of the piston, funnel and the sand particles. Now, just imagine you have removed just one sand particle. Small sand particle. So, if you remove one sand particle, that means the external pressure you have decreased by a very small amount, say dP. So, now the external pressure will be earlier external pressure minus dP. As this external pressure is decreased little, so this gas pressure will be little more than external pressure, so it will move the piston through a small distance, say dV. So it has come here, this is a very small distance. Now after that, if you remove another sand particle, then again the external pressure will be decreased by a very small amount, so now it will be P external minus dP. And as this external pressure is decreased by a small amount, gas pressure will be little more than the external pressure. Again the piston will move through a small distance or small volume, say another dV. Like that, if you can perform an infinite number of steps by removing one sand particle, that means reducing the external pressure very less quantity, then after some time, that means actually after infinite time, you will get a certain or finite volume increase. Okay, that means finite expansion of the gas. So this process is the reversible process. Say here, this is the pressure volume curve of the gas. We are showing the reversible process. And look at here, this is the high pressure. Say this is the external pressure. So this is the pressure. When the pressure is little decrease from here to here, volume is little increase. Again the pressure is little decreased, volume is little increased. Again the pressure is little decreased, volume is increased. So between this any two steps, that means increase in the volume is very small. So it can be any step. So this step, if you can increase little pressure, again it will go to the backward step. So this step. Here this is the volume. Again if you increase little external pressure, it will go to the backward state, back state. That means every step can be reversed back. And this equilibrium is maintained between any two consecutive steps. That means in all time equilibrium is maintained. Now another important thing is that for any thermodynamic system, there is only one reversible path. Only one. This is the path. Here it has gone from this state to this state. And then if it reverses back, it has to follow the same path. Okay. Only one reversible path. Now coming to irreversible process. Irreversible process, just opposite to reversible process, it is carried out in a single step and it cannot be reversed back. That means when it has come to the final state, you cannot reverse back. And all the spontaneous processes are irreversible. Say for example, here also the gas is enclosed in this cylinder and above the gas, and here is some lid and above it some weight is kept. Okay. Now external pressure means atmospheric pressure and this weight, and the gas pressure which is acting upwards, it is acting upwards, and external pressure acting downwards. Now if you remove the weight, then what will happen? Then gas pressure will be much more because you have removed the weight. So suddenly you have removed the weight, gas pressure will be suddenly become more. So this expansion, finite expansion takes place in finite time. Okay, and in one step. So here you see pressure volume curve of this irreversible process. That means against the external pressure, against in external pressure. Now here what is done? Suddenly the pressure is decreased from here to here in one step. So the volume increased from here to here in one step. So this is irreversible process. Now let's compare the reversible process and irreversible process. Already we have come to know the criteria, that only you have to compare. Reversible process, it is carried out through a large number of infinitesimally small steps, and irreversible process takes place in one rapid and measurable step. Then reversible process, practically you cannot do it. Just imagine one sand particle will be removing and little volume expansion. Practically that is not possible. So it is theoretical and it is unreal, and irreversible process is real. Means practically you can perform it. Then reversible process system remains in a state of equilibrium at all times. Okay? And irreversible process means equilibrium only at initial and final stage of operation. Okay? And reversible process, every step, any two consecutive steps are in equilibrium. Every step equilibrium is maintained. So equilibrium is maintained at all times. That is reversible process. Now fourth point, reversible process can be made to go in either direction, either forward direction, and by making little change you can make it to go backward direction. But irreversible process can proceed only in one direction. So these are the comparison. One more point is there. Work done in reversible process is greater than in irreversible process. Let's see. So this is the gas pressure volume curve. Now look at here, this is irreversible process. Suddenly the pressure is decreased from here to here, so volume is increased. So this is single step process, and the work done is equal to the area under this curve. And this is reversible process which takes place through a number of small steps. That means every time little pressure is decreased, so volume increase little, like that, as I have shown you. So this is the path for the reversible process, and it has only one reversible process path. And you see, area under this curve is more. That means work done is more in reversible process and less in irreversible process. So hope you have understood. Thank you.